Python for Data Science program. It's been a long journey so far. This is the third week of the boot camp, and like we mentioned during the orientation, a lot of the learning, it's going to be you're going to do a lot of work learning on your own. And then the essence of the class sessions is to have like a review of what you're supposed to have learned on the LMS, and then to attend to questions that you might have. So if you have any questions, you can add to the Slido link that was just posted to ask your questions. Okay, and I hope you've been having actually learning during the course of this journey. This module is going to end on Friday, so we have pretty few more days to the end of this particular course. So I want you to make the best use of the time that we'll be having now together and the final session. So today's class, we should be covering data exploration with pandas. We started with pandas package last class, and then we did a recap on data input and output, indexing and selection, pandas, merge, join, and concatenate. So the class recap sessions, right? We used a walkthrough, an exercise walkthrough to cover these concepts. So if you missed that class, you can check up the recording. And we would be using that same approach today. So we'll be working with a data set and to recap what we are supposed to have learned on the LMS. So we have videos on the learning platform of previous boot camps where these concepts were taught in depth. It's going to be linked on this recording, and as well, you can have those access to those videos on the LMS. Okay, so we'll be getting right into what we have for today. We'll be doing the recap for about 15 minutes. Then we'll be having a quiz break for 10 minutes and Q&A 15 minutes. And then we'll be having the final wrap-up session. All right, so today we'll be looking at analyzing how to use pandas for data exploration. And then we'll be touching on a bit of data visualization using Seaborn. So let us get started. So there is this data set, the serial data set that we'll be working through. I'm trying to open the LMS to see if it was linked. If it wasn't, it will be shared, it will be linked on to be attached to the class recordings table. There is a class, there is a lesson on class recording, and you have a table where we have all the recordings, right? So if this data set is not on the LMS, we'll be attaching it to that table so that you can access it and for your practice. All right. Okay, so let's get started. Like I mentioned in the last class, the pandas package is a very great package for data manipulation, and it's very efficient when it comes to analyzing large volume of data sets. Part of your job as a data analyst or data scientist is that you are going to be doing a lot of generation of insights. You want to find out about the data before you. You want to find out more about data sets. You want to understand relationships. You want to know what questions, what real life questions you can answer from a data set. Data on its own, when you see a CSV file or an Excel file or a JSON file or data in a database, it might not give you the true picture of what the data is about. But when you have tools like Pandas and SQL, and some people use Excel, all right, but then we are in the Python class. So Pandas would help you to further analyze your data, that is to generate insights to answer questions about the data that the data would not tell you at a glance. Okay, and so that's why we are learning. So I'm going to take you through a real life data set This is a serial data set. It's available on Kaggle. So the link of the data set, like I said earlier, will be attached on the LMS. So there is this 80 serials Kaggle data sets, okay? All right, it will be, let's just go right into what we have because of our time. So this data set has different it has so many columns, okay? So in the process of data exploration, you'll be finding out what are the basic thing about your data set. You want to find out the number of columns, you want to find out the number of rows, you want to find out key things about your data set. You want to find out if there are missing values in your data set. You want to find out some important information in your data set, and the pandas would help you achieve that. So given a real life data set, how do you approach the problem? Okay, so the first step is to what? Import to your import statements. You might be using NumPy, so you import some common libraries that you might be using for your analysis. And we have the NumPy package, the pandas package, the Seaborn, which is a visualization package, and then the matplotlib, which is also a visualization package. So I haven't imported those libraries. The next thing to do is to read in your data set, because of course you want to see what the data set is like on your notebook so as to further analyze your data set. Okay, so to read in your data set, you use your pd.read_csv, because I have a CSV file, and in my directory, you can see the CSV file here called serial.csv. And normally, if you open the CSV file, if I'm going to open this CSV file in my directory, it's going to look very scattered, and it's not giving me any great insights. Okay, but reading it into using the read_CSV, can see how the data set looks like. It's a comma separated value. It's in a comma separated value format. So you have the name, manufacturer, type, calories per and all of the columns, right, in commas, and all the associated records all down. Okay, so here you can't really tell, you can't make sense of it. If I ask you what is the highest cereal, what is the cereal with the most calories? It's like Greek. You can't really tell me anything from this. But when you use your pandas package, you see that you can answer some questions that we'll be looking at today. All right. So when you're reading in your data sets, you use your period of readers called CSV. We addressed that in class. And then you ensure that your CSV file is in the same location with this notebook you're working on. If not, you'll be getting an error. So you can see that my notebook and my CSV file from my previous view is on the same in the same location. All right. So and then you can set the index column. That is, I want my index column to be the name column. All right, because sometimes when you don't set your index column, you might get a default index generated by pandas called unnamed. Okay, so if you don't set an index column, the pandas can give you a default program column as your index. So here I'm setting my index column as my name because I want the name, all right, to be the index. Okay, and okay, and then we can move on. Now, after reading your data set, you want to see the first five. So there's this .ed function in pandas where you can use to see the first five records in your data set. So this is how the data set looks like. Okay. So I've loaded it, and then the next thing is to check the first five records. And if you can also specify the default of the ed gives you first five. You can specify that you want to see the first 10 and give it the a number, and this you can see that it's giving you the first 10 records in that particular data set. So pandas helps you to do this efficiently. when you're doing your analysis. So when you're doing your data analysis process, like I mentioned in the last class, that as a data analyst, right, you want to, beyond just um gathering data, doing data entry and all of that. In the data analysis process, you have the data munging, the data exploration phase. And in the data exploration phase, that's where you want to find out more about your data set. You want to ask real life questions about the data set. All right. And so skills like pandas would help you achieve that. So you check the records to see what it's like. You can check the shape, use the dot shape function method to check the number of rows and columns. So but at a glance here, you can't tell how many rows and columns that is in your data set. So use the dot shape to check the number of rows. So here the dot shape is telling us that we have 77 observations and 15 columns. Okay, so in real life, you might have millions of rows in your data set, and you can have many columns in your data set as well. Okay, so your skills in pandas would help you know how to analyze this large volume of data sets. All right, so moving forward, we have to understand our data set, because if you want to actually solve a problem, you have to have like even if you're not a domain expert, you have to have like some basic understanding of your data set. Like, what is it about? What am I dealing with? So from the data description, so usually when you're having a data set and maybe you're working independently from a company, and maybe you have a project to do. So you're usually supplied with the data description or data dictionary, where you have apart from the data set, you have like the description of what your roles and column. That's what this is telling us, the description of what each role is. So we know that name is name of cereal, MFR is manufacturer of the cereal, type is whether the cereal is auto code, calories, the calories per serving, protein, grams of protein, fat, grams of, and all of that. Okay. So, but then there are times whereby you have to do your data gathering yourself. Like as a data analyst, there are several ways to solve a problem. Number one, you could be a data analyst uh, in a firm, in an organization. For example, you're in a sales organization that is into sales, and you have access to the database, all right? That the database is just there. Maybe they always sell. It could be a supermarket, it could be a grocery store, it could be anything, it could be Amazon, it could be any of this online sales company. And then you have because it's a company, probably there's a database where their data sets are stored. So, and then you're asked to begin a research on how to improve the business using the data they have. So you have to now start investigating. Okay, do I want to deal with what the problem am I trying to solve? What am I trying to? You must have like a business objective. What do I want to do with this data? You might be given a data set of customers, sales, purchases rather, how people have been purchasing items from that particular company, where you have the customers, maybe identification number, you have some other details about the customer, and then the way the customer has been purchasing. So based on that data you've gathered, you'll now have to start deciding, okay, what's the next step of the problem, of solving that problem? What kind of problem am I trying to solve? Okay, so you have to, after gathering your data, you now have to start investigating your data set, and that's what you're doing in the exploration phase. Okay, so for this particular problem we have at hand, this is a serial data set where we've gathered different cereals from different manufacturers. I'm sure many of us you're used to, you might be familiar with some of the cereals, right? You have the name of the cereals, the manufacturer, the nutritional content of that cereal, and then you want to find out some things. At a glance, can you tell us, out of maybe 80 cereals that you've gathered, different cereals, which cereal would have the highest calorie per serving? You might not be able to tell, but in data exploration phase with using pandas, you can be able to tell. And then you're now a thought leader. You can, because you've actually analyzed the data, you cannot tell publicly that, okay, that in a particular among the cereals that I've analyzed, you have to be aware of the calorie content in so and so cereal, because this is the number of calories per serving. I believe you understand what we are trying to do here. All right, so moving forward quickly because of our time, we will be looking at the shape. We've seen that we have 77 cereals, and then we have 15 columns. All right, and then you understand what the different column names mean. If you don't understand, you can go to the data dictionary. All right, so the next thing is let's check what the columns are named, like what are the names of this column. So if you want to do that, all right, so you can, so as you're analyzing the data set, you're writing. That's why Jupyter Notebook is great. You can begin to take down your observations. So here you can see the serial has 77 observations, 15 variables. Now you want to see what the column names are. You can use the data.columns, and then when you do that, it's going to return the number of columns in your data set. And then if you want it to give, you want to get the columns not in this index format. All right, so this is a list. So that's where your knowledge of Python comes in. Python for data science that we are doing now. During the first week, we looked at the variables, data types, the loops, and all of that. So if you have this list and you want to get out the individual column names without this index and all of that, so you know that this is a list. So you can look through this list and then print out each of the column names, and then you get out the individual column names. All right, so there are several ways to get a view about your data. You can have the head, the info. You can use the describe, which we've shown above. So the head gives you the first 5 rows by default, then, but you can increase the volume. Okay, there is one more. There's .sample as well. So we can have the .sample. We have the sample. Method provides samples of numerical data, of the data set, not just numerical data, samples of rows of your data. So you can define the number of samples. So I'm going to show you a couple. So we've seen the .info, right? We've seen the .ed rather. Now this is the .info. So the I'll show you what .sample looks like at the later end of this notebook. All right, so the .ed gives you the first 5. The .info gives you the information about your data set. Now, at a glance, .info tells you, okay, we have 77 entries from 100% brands. So it's even telling you the first item name from 100% brands to the last index. All right. 100% brand to Wheaties Honey Gold. I don't know how many people have eaten any of the cereals. So you're learning something. So the beautiful way to start up in data analytics is to do something around what you love. Maybe some interesting data sets, some data set that might excite you, or interest you. That gives you like that motivation to want to research into what the data set looks like and all of that. Okay, so if you're a cereal lover, I like cereals. So this is an interesting data set for me. All right. So we have the entries 77, 100% brand to BT's gold. And then it's telling us the number of columns, which we already know from the dot shape, 0 to 14. All right. And then here you can see that it's telling you that your data set does not have a null value because it's 77 entries on each of the columns. Assuming there are sometimes in real life, you might have missing values. Maybe you might have some columns, 0, some 5, some maybe 70. But here you have 77 all round. So it's giving you like the information about your data set, and then it's telling you the data type for each of these columns. So you can see that manufacturer's name and type is an object. An object is like your string. If you look at the data set up there, you can see that this is like your string or your character. All right, so it's telling you that object, but calories to sodium should be an integer. Okay, so you can see that it's telling you calories to sodium is an int, fiber carbo, it's floating point number. So it's good you have an on, because when you get to machine learning, you need to know how to deal with all of these data types. So it's good to have like an overview of your data type. All right, moving forward, use your describe function method to check for the descriptive statistics of numerical column. So at a glance, you can see that all the numerical columns, those are the ones with integer or floating point numbers, like the calories, the proteins, the fats. Okay, you can see here that you might not really know. If I tell you that what is the maximum fats, what's the maximum fat in this data set, you might not know. What's the minimum? You might not know. What's the 25% percentile? So that's what the descriptive statistic is telling you. It's telling you the distribution of each of the columns within the numerical columns now, because the descriptive statistic will not give you the describe will not show you the other ones without that are not numeric, because by default it's defaulted into numeric. So if you check for what it looks like, so it's going to say it describes the percentile, includes, and so you can see that it's just going to include only the numerical function of the numerical columns. All right, so you can see now by here when I come to the description, I can see that the minimum fat 0, the maximum is what, 5, because I have this table, right? And then the 25% percentile is 0. That is 25% of the values of the rows in my data set have 0 as their fat. That's 25% of the serials, of the records that because we're dealing with serials, that's what I'm saying, serials. Of the records in our data set are 0 as a fat, 50% has 1. So we have a good number. I mean, half of our serials, the serials in our data set just has one percentage, one fat. That is the fats, amount of fat, when you check the nutritional content, the amount of fat in the cereal so is very key. Like you want to check the sugar level, you want to check, I hope I'm not consuming so much sugar content, hope this cereal is not high in fat, and all of that. So you can see that okay, these cereals that we have here, they are kind of LD cereals. Okay, then if 75 is going down to 75% of data set, we just have 2. But then the maximum number of cereals, maximum number of fat is what, 5. And if you want to check the sugar, which some persons might be interested in, the kg of the sugar, we have the minimum number as -1. Oh, so there is a cereal with a -1 sugar. Is that possible? So, now there are some things that you might be also looking at when you're dealing with your data sets. Most especially when you get the machine learning phase, we'll be dealing with outliers. which are out of range values. That is, they are values that are really, really out of range compared to what is in the range, the normal range of the values in your data. So for example, maybe you have age, all right, in your data set as a column on your data set, and you're seeing a age like 1 million. Of course, nobody can be 1 million a year out of range, of age. So that's an out of range value. Or you see an age that is telling you minus 3.4. That's you'll be sure that, oh, okay, this value is not entered correctly. You understand? So all those kind of values, they have to be dealt with when you get to your data cleaning phase of your proof. So, but what we are doing now is data exploration. So you start taking note that, oh, okay, we can't have -1. I don't know. Then you know, sometimes you might need a domain expert when you're working on data sets. And that's why most times as a data analyst, data scientist, machine, you don't work in isolation. You usually work in teams. You have maybe somebody that has the knowledge of, maybe like a nutritionist or a dietitian that knows what has domain knowledge of all this nutritional content. Then you find out, oh, can you actually have a sugar as 1.1? And then the person says, oh no, okay, then you know what to do with it. But if the person says, oh, okay, there are some things, there's some indicators and all, then you know that, okay, that it has to be there. All right. So the sugar, from like a general knowledge, I feel that you can't have sugar content as -1. So I feel there's something wrong with that -1. So that would be a kind of a point of interest when I'm doing my data exploration. I want to know how many cereals have sugars as their -1. Okay. So moving forward, I've just explained what the describe does. So it just gives you the count. It tells you the number of records. That's the count. The mean, we know what mean is. The mean is what the average value of what is in your column, and then it gives you the standard deviation from the mean. All right. So when you're doing data analysis, so you have to know a bit of statistics, some statistical stems when you're doing machine learning, so as to like understand how to interpret your data. You have to know like a bit of some bits of statistics will help you. All right. So we have minimum value, the 25% percentile, 50%, which is the median, 75%, which tells you how 75% of data set in that column is doing, and then you have the maximum value. Yeah. So I believe I've dealt enough on describe. So we have the last function, which is the sample, which I said I was going to talk about. So you can do your data.sample as well. So you have data.sample. Data.sample just gives you one sample of record on your data, any sample, no particular order. All right. So the sample just gives you like a random return of, so you can decide to specify, okay, I want 6 samples, and then it gives you like different mix, like a mixing up everything in your data set and returning it to you based on the number you want to be returned, you want to have returned. So you can see that in my original data sets where I have them in a particular order, I can't see there's no I wouldn't know the kind of cereals that are there. And then here I can see that they are kind of alphabetically ordered, like you have the A and the B following. Here you have like a mix where you have the clusters, the mueslis, the shredded wheats. Oh, I like shredded wheats. Shredded wheats, brown, golden, grahams, and you kind of see what sample. So that's another way to view your data set. I just thought to mention that so that you can also know that. All right, moving forward, you can do your length to check the length of your data, right? Now, you can decide to check the descriptive for a particular column. Maybe you can pick a column. How do you access your? Now, that's why we went through the last class with explanation how to access a single column in your data set. You can just do data.calories. Data.calories without the describe, right? This is what it gives you. You do data.calories. It gives you the that particular column, everything in that particular column. You can also do it like this. Either way, there are several ways of accessing a single column. You can do data calories in square brackets. All right, it also returns that particular column for you as a pandas series. Okay, so but here I want to see data.calories. So let me just undo this so that I can just do the dot subscribe to check the descriptive to check, sorry, I didn't put the function in the correct order. The descriptive statistics of this particular column. Okay, now you can also check for unique entities. For example, if I tell you there are times that in this particular data set, all right, they had some same cereals with the same different cereals with the same manufacturer, like this all brown and all brown with extra fiber, the same manufacturer. This person was manufactured by, this cereal was manufactured by K. So can you tell the number of manufacturers in this data set? How do you find out that? How many unique manufacturers do we have in the data set? So you just have to use your dot unique function. All right, so that's why you're saying that data, that is the name of the data frame, data dot the name of the column, which is MFR dot unique. So that returns what? All the names. So here you can see that we have like 7 manufacturers in the entire data set. All right, but now, knowing that, okay, so these seven series were manufactured. So those are informations that you can, start penning down. Okay, in this data set, we have 7 key unique manufacturers that manufactured this 7 series. But if you want to find out, can you count how many cereals were manufactured by these different 7 manufacturers? That's where your value count comes in. So when you do data, that is the name of your data frame dot the name of the column dot value count. So this value count gives you the count of every that is telling you that manufacturer K has like 23 cereals manufactured under its name. We have manufacturer G, 22 cereals manufactured. So with these functions that we are using, right, you are already doing your exploration. You can start telling a story about this particular data set. Okay, you can say that, okay, the data set I'm actually analyzing, we have 23 cereals that were manufactured by K. K could be any Kellogg's, right? 22 cereals were manufactured by G. I don't know what G is, right? If you check your data dictionary, you might find out. Another 9 cereals were manufactured by P, and so on. Okay. So moving forward, we can also do a pivot table. You can use your pivot table to check your calories by manufacturer. So the pivot table, I know for people that do Excel, you know that pivot table is a very powerful table. It helps you to summarize a large volume of data. You can have a large volume of data summarized on the pivot table at a glance, and you can see what each column or represents. Okay, so we can do a pivot table of calories against manufacturer. And then when you do a pivot table, it's easy to do like aggregation on your pivot table. Okay, so calories by manufacturer. So you can see that the entire manufacturer, hey, all the cereals that the manufacturer A manufactured has like 100 calories. Manufacturer G, you have like 111 calories and so on. Okay, so you can also have pivot table calories by manufacturer by type. That is, you want to see. Now you see that the manufacturer is on the right, and because that's our index. So we have the manufacturer on our index, and then you have the type above, which is what's here. You see the type can be C or H. If you see, it can be what? Hot or cold, right? Which is C or H. You can see the type here, which is C or H. So you can see the pivot table is helping you to aggregate summarize your data set at a glance. And then you can see that for this manufacturer, the cold cereals, right, has like, this one doesn't have any calorie, right? This one has like 111 calories for this the cold cereals. Now, you know, for every manufacturer, a manufacturer could manufacture more than one cereal, right? We've established that from our value counts. But then each of those cereals, they could be cold or they could be hot. All right. So we can use the pivot table to aggregate, to summarize our table such that you're seeing that the manufacturer, all right, is divided into type, which is cold or hot, and then for each of those cereals, the number of calories that they had manufactured. So now let's go into selecting columns. All right. So you can decide to streamline your analysis. Maybe you're interested in some columns. Sometimes you might have like 100 rows or 100 columns. I believe we know what columns means. Columns are what? The vertical they are vertical information in our data set, where the rows are like the records, the entire records. So a column can be like an age, can have age as a column, you can have your first name as a column, you can have last name as a column. But for an entire record, you can have a student, right? You can have somebody's identification number, maybe a personnel in the company record with its first name as James, last name as Fred, and then you have other information about that person on different columns. So that's the record. So I believe we understand that. So you can have the record of many, like here we're having a record of different cereals. Okay, so moving forward, we can decide to say, okay, I'm interested in the calories, manufacturer, carb rating. So this cereal is like the cereal data set of different cereals, right? And what a user, what the rating of that cereal is. So you can see 100% natural bran was manufactured by K. Okay, it's Q, it's a cold cereal, has 120 calories, protein, and all the information about the cereal. The weight of the calories is 1 kg, number of cups, and then user rating 33.9. All right, so let's move quickly. All right, so we have this information. Now, for you to do your selection, you can create another data frame, all right, and then define the columns in your selection, in your data set. So there are different ways you can do this. I'm going to do it in another way. So you can say pick your data frame, your data, then column names would be what okay. Column names will be what? Calories, manufacturer, cups, rating, and costs. Now, because there is no cost in our column, you see that it's going to return NaN as our as the information for costs. Now you can see that there's no cost in our initial. There's no cost here. But when we're importing our tables, our column names, excuse me, when we're importing our column names, you'll have costs added. So it's going to tell you that not a number, I don't know that information. Okay, so that's the first way to select interested column. Another way to select your column is the what? You can do the name of the data, then a double square bracket, and then the names of the columns you're interested in. These are the names of the columns I'm interested in. Since it's a data frame already, you could just do this. But we're doing this, it's going to throw an error for cost, because cost is not a part of the key. It's a cost not found in index, right? So you cannot have that in when you do that using this format. So you cannot, if you do this, it's going to give you a data frame with calories, manufacturer, cups, and rating. All right. So that's another way to select. Maybe you want to create a slice of your data frame. If you want to just extract few columns. So you take notes, double square brackets. When you're selecting just a single row, for example, I just want to select only calories, right? So I can just use my single square. If I use a double square bracket, it's going to throw an error. I think so. Okay, it still works. Okay, but then by default, it should be a single square bracket. All right. Okay. So what double square bracket is converting into a data frame. All right. So I just thought to mention that we might not have to, use that. So now you notice that cost is equal to NA because it didn't exist before selecting it, which we mentioned earlier. All right. So if you do this as well, not including this does not work. Why doesn't it work? Because we have a key error. Calorie, manufacturer, cups, and rating is not in this table. All right. Okay, so now moving forward, we have selecting multiple variables, but not cost. Like I think I just mentioned that I haven't forgotten that this was there already. When you want to select more than one variable, but not cost, which I just mentioned earlier, you can use your double square brackets, right? But if you include cost, it will not work. Okay, you include cost, it's not going to work. And this one not working. I mentioned if you're selecting more than one column, you use your double square brackets. That's why you're not, it's throwing an error. It's telling you it's a key error. All right, moving forward. Now, there are times that you might want to recreate a column. Maybe sometimes you might want to create extra columns that are not originally in your data set. Maybe you have the weight and height in your data set of a particular person. I want to create the BMI column. If you know the formula for BMI, it's easy to create a new column. In Excel, you could just put it in your formula bar. You could just put a formula and then you double click and it does the rest for the rest of the row. But in Python, it's different. Okay, so you have to create the column, the name of use your data set, name of our data set data too, because of the slice. We can decide to set a default cost, right? 3.5. And how do you assign variable? Like we learned when we're doing our lists and our dictionaries. Now, when you want to assign, you want to update a list or dictionary, you have to use your location. You select that particular location. And in this case, we want to select the column where we want to create. We're trying to create a new column called cost. So the name of the data set, then you have the cost equals 3.5, which is if you want to use any formula, you can now impute the formula here. So assuming I want to do like calories multiplied by costs, you can put that you can put that in here so that it does the calculation for you. But here we just want a default value for all the costs here. So that's why I'm doing this. So we have set all the costs to 3.5, but then we want to, because we are trying to generate, we don't have the data imputed. We don't have the information. We're trying to generate a random cost. We don't want everything to just be 3.5. We can decide to use our NumPy. Now, your knowledge of NumPy is coming to play here. You can decide to use your NumPy function to create a random uniform distribution for that particular column. Use your np.random.uniform. You're setting the lowest number, that is the lowest number in that distribution should be 2.5. The highest cost should be 4.5. And then the length, the size, that is the number of, when you're giving your random, you have to set your the numbers that you want to be in your random distribution. All right, so you have the size, that is the number of elements in this part. How many rows are we talking about here? So how do you get the rows? When you do your length data, so it tells you that it's the length data too is what 77. All right, so this is just saying size. I want the size to be what 77. But beyond the size being 77, I want you to round up the because a random number will give you like a long floating point number. So I want it to just be in 2 decimal place. All right, so that's what this dot round is doing. All right, so I haven't given you the numpy function, then I want you to round up the value, and that's why you're having this. Okay, so now you have all of this. So when you now want to, you can now decide to set your costs. The cost that it was originally there, here, this 3.5, you're now updating it. So to update it, like we are using the random.seed so that we'll be having the same value. You can now decide to update this data to cost equals, you're renaming this function, right, as cost, and you're updating it. Instead of 3.5, you are using costs. That is this random uniform distribution has been created up there. Okay, now, so you can see here that the cost column has been updated with all those random numbers. So now you've created a new column from your initial column. Okay, we have a lot to cover, but let's see how far we can go. Now, note that when you are assigning values to your random number, all right, it has to be a correct size. I mean, to your when you want, for example, I want to update this cost column, right? I want to update every element in this cost column, and I have just 77 rows. But if I give it a 78, if I give it 78 rows, it's going to throw an error because the value has to be the same. I mean, the length has to be the same. So here, assuming our size was set to 78 instead of 77, you see that there is an error down here. When we run it, there's an error down here that says maybe something out of range or something. Okay, length of value 70 does not match length of index 77. So length of index is 77, but then it's getting values of 78. So it's going to throw an error. So take note of that. Okay. Now, we're still explaining how to explore your data set. Sometimes you might want to create a Boolean column, like maybe a column that would tell you that gives you like more information about your data set. Now, I want to check the costs that are greater than 3.5 and create another column, right, for that particular value. So here we have a cost 2 column, that's another column, right? So this column is going to tell us whether the cost here is greater than 2.5. So that's what this is doing. So creating a new column called cost2 equals data.costs. Like I mentioned earlier, like if you want to perform any formula function, you just put your formula here. If you want to perform addition, subtraction for a new column, all right, so you can put it at the right hand side and then assign it to the new column that you created. Okay, so here you're saying that for every cost in this data set, check if it's greater than 3.5. Whatever the result is, save it as cost2. So here it's going to check 4.47 greater than 2.5, true or false, true. 3.17 greater than 3.5, true or false, false. So I believe you understand what that is doing. So that is a way to like identify the values or creating a column for that purpose. But we don't need it. We don't need this column. It's not necessary for our analysis, but this is just like an example of if you want something like that in your analysis. All right, so we can use the del function or delete to delete that particular. So how do you delete a column that you don't need? You can use del or delete. Then you state the column name and you select the column and then it deletes, and then you can see that you have the column deleted. All right, let's move on a bit. So for example, now let's start doing some small selection. So we'll start selecting some rows and all of that in subsequent analysis. For example, we want to select columns greater than 3.5. Like now we are not using creating a new column. We want to just select all the columns that are greater than 3.5, that the costs are greater than 3.5. Here you can use, let me just create another column so that I can show you how it's done. Now, the first thing to do is, what's the name of your data set? The name of our data set is data2, right? This is a long data set. And then out of all this, we have 77 serials. We want to see, okay, how many serials are their costs greater than 3.5 pounds or dollars, right? So you can now say data, but because we are looking at costs, so we would have to refer to our cost column. How do you select your cost column? You remember, first of all, refer to your data set. Before you select your cost column, you say data 2, then the name of the column, costs. All right. So when you do that, what this does is going to select all the, sorry, okay, I think I made a mistake. Sorry, okay. What this does is costs. There is a key error somewhere. So what this does is it selects all the data, the cost column. That's just the cost, the entire cost column, right? The ones that are greater than that's the first thing you're going to do. You're going to select the cost column first, but because we want the ones that are greater than 3.5, we're going to say greater than 3.5. So that gives you the columns that are greater than 3.5, but it's giving you true and false. Because we want to have the entire data set returned, we can now enclose it in our data too. All right. And then when you do that, it returns the data sets that are greater than 3.5. I don't know if you get that explanation. So it returns all the data. If you look through this cost, you see that none of them is less than 3.5. So here, you're able to filter out of your entire 77 serials, the serials that actually expenses that are higher than 3.5. Okay, so when you do that, so that's what this is actually doing. Then you're saving it into a new data set called data tree. So you can create a lot of slices out of your data set based on what you're trying to achieve. Okay, so when you do that, you can save it into a new data set, into a new variable called data tree, and then check the 5 records. Okay, and now you can see that out of all the records out of the 77, we have 35 greater than 3.5. 35 serials have their cost greater than 3.5. So that's another way to find out more about your data set. So you can also print out that serial in okay, this was what I was trying to explain earlier. All right, where you can actually select individual records and check their cost greater than 3.5. This is return a true or false. If you want to see the entire data set, you enclose it in the name of the data frame. Okay, so now let's look into selecting columns and rows. How do we accomplish it? We touched on this last class, where we talked about the lock and the iLock, where the lock is you select using the axis labels, that is the name of the indexes. That's like 100% brown. But then if you want to use the location, that is the index, the integer location of like 100% brown is what allocation 0. So use the iLock. So we want to see how to apply that on this data set. All right, so referring back to the initial data set, we have the first 5 records, and then you can decide to say I want all brown. I just want the record of only all brown. How do you know? We've talked about indexing across columns where you use the double square or the square bracket. Now we're talking about how do we extract individual records. All right. How do you extract maybe a single record from the data set, maybe more than one record or whatever you. All right. So you use your .loc when you're using the label that is the name of that role. So at this is the name of this particular role of this particular record is Al Brown. Now, this name is not just the name, all right? It's not one of the columns, it's the index. Like the column, though by default, your index is always like maybe 0, 1, 2, 3, 4, 5 downwards. So, but then this index has been renamed as the name of the serial. And that's why we are able to reference it in this analysis. Okay, our time is fast spent. I don't know how far we can go through. Let me see if we can cover some concepts before we close. Okay, so let's see how far we can go before I don't know if we start dropping your questions. We don't have any question yet. Okay, we have one. Okay. I said if he's not there, we'll check if he's not there, would it will be dropped on. Okay, anyways, we'll attend to questions during our question and answer section. Okay, so we have the lock, which I mentioned. For example, we want to select the entire all brown. Okay, how do you do that? You can use your data, that is the name of the data set .loc, and then the name of that column, the index name of the column of that row rather, and then it selects the entire record called all brown. Okay. Also, if you want to use the position number here, all brown is at position 2. That's where you use your iLoc. Okay, so if you use iLoc and put the name, it's going to throw an error. So this is indexing the same thing, but because you're using different values. So you can also index the it can indicate rows and columns that you're actually interested in. As you're indexing the rows, you can also say I'm interested in the column as well. So you can just do, instead of you can do loc, then the name of the column here, I'm interested in the facts. So if I can just say loc facts, and then it returns the fact of all brown to me. All right. Okay, so if I want just everything, I just have this as well. All right, so that's what that is doing. Like here, whole brown fiber, it's returning that. Okay, so you can also use brackets instead of parentheses. All right, so but then let's move forward. Here you can index, for you to index more than one location, like you want all brown and almond delights, you can use your double square column, comma, and then the name of the column that you're referring to, and it returns that. Okay, you can also use your double square. For example, your double square all brown almond delights for 2 rows, and then the columns that you want to index out, fiber and manufacturer. So I believe you understand. So I want to add more because of time. We might not be able to go through. For example, let's just get out. Okay. I want to see. I want to index out, not leaving the loc and the iLoc. I just want to give, like, for example, I want to index out. I want to find out the cereals that have their carbohydrates greater than 7.0. So how do I do that? You can say data, that is the name, the condition first, data. What am I referencing? Sugars, right? greater than 7.0, or it can even be greater than equals to 7.0. Okay, and that is the condition. But if you do that alone, it's going to throw an error. I mean, it's just going to give you the true or false. So you have to enclose it in the name of your data frame, and then it's going to return all the serials that are greater than 7.0. So here, for me, I might not be able to check the account. Let me just check the counts or the shape. So I can see that 39 serials are their values, their sugar levels greater than 7.0. Sometimes you might have to combine functions, like you might want to do more than one. Sorry. Our time is fast spent. Sometimes you might want to say, I want to filter out sugars. Let's do something else. I want to find out calories, protein, and fats. I'm focused on some calories, protein, and fats, okay? And then rating, you can just say something like this: calories, protein, fats, ratings. You have to put I want to focus on these two, this items, okay? Yeah. And I want to see the ones that I want to see the cereals that have their rating. I can decide to create a slide called data 5. Okay. Okay, so I can say data 5. I want to see the ones that have their ratings. Can I see the one that has like the cereal with the maximum fats, that has the highest fats? So I can say data 5 fats dot max. First of all, let's check the condition so that we will be on the same page. So you can see that data 5.max, that is the maximum of value size of the cereal, of the maximum value for fat is 5, right? So, but then I want to see that which cereal has their fat as the maximum. So how do you do that? So you first of all get out the maximum value. You can say you can give it a name. I'm going through this step by step because of for our understanding's sake. And then you can decide to say that data 5 parts equals 5 as your condition. That is, you want the cereals that have the cereal that has is maximum value equals 5. Its maximum fat equals 5, and then data 5. So you can see that 100% natural brown is a cereal with its fat as equals to 5. Okay, so it's just one cereal. So you might have more than one at some point. Maybe when you're using different, maybe calories could be different. So this is a way to like find further investigate more. So there are different conditions you can check when you're doing your data exploration. You can also look at rating as well. You can check, okay, which cereal has the highest rating. You can change this to rating. All right. And then you can now say what the rating. So here, because I know, sorry for using this 5, you use the maximum value because that has given us, so that we are flexible with our with our code, what we're writing. So you can have this as rating as well. And then it gives you the serial with the maximum. So we have the serial with the highest rating. So in this data set, we can see that all brown has, with extra fiber, has the highest rating. Okay. So if we also want to check for the minimum rating, we can change it to minimum. All right. And then you can see Cap and Crunch has is the serial with the least number of rating. So there are several things you can, depending on what you're trying to find out. So as a data analyst, like investigate so many things about your data using your knowledge of having to manipulate data sets. You can have different business questions that you're trying to ask. Okay, so when you get this notebook, you can just try to do this practice, for this exercise. We'll attach the notebook to the LMS. All right. At this point, we'll go on a quiz break. It's been a long time, going through that data exploration serial data set. But I'm sure you got one or two things. We're unable to touch on. We're supposed to look a bit on Seaborn. On Seaborn, data data visualization using Seaborn. I know the explanation is on the LMS. We did some quick explanation on the LMS. Let me see if I can look through something quickly. Okay, I think let's do this. Gosh, this is a long. Do we have time to do this? Okay. Let's try. Let me just run through this quickly. Then we'll take our quiz. All right. So Seaborn is a data visualization package, just like Matplotlib in Python, and it's used for aside just doing your data exploration, you want to also use some graphical you want to have like a graphical view of your data. You want to be able to see, you want to be able to visualize in the picture of what these relationships are. Okay, and that's why you use visualization. For people that want to go into in-depth business analysis, visualization, core visualization, you'll be learning other visualization packages like Power BI, Tableau, and some of these visualization tools. But in Python, in data analysis, you'll have to also do some visualization for the sake of machine learning. Maybe you want to check the relationship between your data sets. There's some different plots that you can plot, that you can carry out, and all of that. So I'll just run that through this using the Titanic data set. So to use the package, like every other package, you have to pip install Seaborn, all right? And then you can now import it into your notebook. Okay, so after importing it, you can set a style for using this SNS.style, set style, and then you load there's this Titanic data set in your Seaborn package. You can load it, and then the Titanic data set is a popular data set of the Titanic crash that happened, all right, of passengers that survived, their class, the gender, the age, the different columns in the data set. Now we want to plot some graphs, okay, in this data set. Now the first thing to do is we want to use the join plot. And what the join plot does, okay, so in plotting graphs, we have different type of data type. The data the data, well, I'll call it not data types now. The way your your column looks like. You have the numerical columns, you have the categorical columns, and then you have the nominal columns. All right, so you have this, like this survived where you have classification. Those are categorical columns where you have 0, 1, 1, 2, 3, or something like that. Those are categorical columns. So when you're plotting some graphs, you have to understand when to use how what plot works for what kind of column distribution. Okay, when you're doing a joint plot, you're doing a pair plot, you're doing a box plot, you have to understand. So for you to learn more about the Seaborn package, you can just go to Seaborn, Seaborn documentation. Seaborn documentation. This is documentation here. We have a very robust explanation of how to use different graphs in Seaborn. So here you can come to the tutorial. When you come to the tutorial, it tells you the different different plots you can use for Seaborn. So I'm going to click on this tutorial guide. So here, so you can see the different plots you can create. So you're going to start looking at what Seaborn is, how to set themes, load data sets. This is a real plot. So if you go through this documentation, you have like a very robust understanding of Seaborn. We also have the Plotly. The Plotly. Plotly is also a very good Python. It's also a very good visualization package. It's great for maps, like all those visualizing maps and graphs. It's a very, very great package as well. So once you understand the basics of using Python, right, you'll be able to quickly navigate to all of these visualization tools, like Plotly, like Seaborn, like Matplotlib, and all of this. They have their own they have their tutorials as well. So I'm just going to quickly navigate to, okay, it's still loading. Okay, while it's loading, let's go back to this. Okay, so now we want to create a joint plot. I was trying to explain the different types. So we have the categorical, right? We also have the numerical data sets, like when you have your floating points, the floating point numbers or the integers, but they are not in a particular category. Okay, so like when you're doing a joint plot, you can only plot it with two numerical data set, like fair. Fair is like price, and age too is like numerical data set. So what it does is that it's going to create a plot. It's usually, you can define by default, this is more like a scatter plot in between. So it's going to plot a fair on the x-axis and age on the y-axis, and tells you how the relationship between your fair and the age. So here you can see that there is no it looks like a positive relationship, but then relationship is not very defined. So if you want to see if it's a strong positive relationship, that means there should be like a long thick line, like a regression line, where you have all the points gathered as a diagonal line. That is telling you that maybe as the fair is increasing, the age is increasing. So here you can see that there's no really, it doesn't really have much, there's no relationship between fair and age, because here you can see that the ages between we have like maybe 0 to 50 years of age. So the age is like this, and the fair, as at age 10, the fair is still the same. The fairs, even from between 0 and 10, you can see that the fair is stronger around 50 to 100. So this relationship is not well defined. All right, so you can decide to check other relationship using your joint plot. You can decide to check here it's just fair and age we can check. because those are two numerical columns. Yeah, the others are categorical, so you can't really do that with a pair plot, a joint plot. So, but then it gives you both the regression, like a scatter plot inside, and then it gives you the distribution of how each of those columns look like. So here you can see that the fair has this a right skewed distribution. So we'll be talking about machine learning class, we'll be talking about the skewnesses and what skewness is, right skewed, left skewed, and what a uniform distribution is, because that will help you understand your data, how to approach a machine learning problem. Okay, so here you can see that the data is skewed to the right, and that is the mean, and the standard deviation is towards the center, towards the left hand side. And then here, this is looking like more like a normal, it's not so normal, a normal distribution where you have the mean and the standard deviation, the median, mean and the median rather, it's aligning towards the center. Okay. Moving forward, let's just talk about some other little plots, and then so we'll talk about the distribution plot. The distribution plot helps you to check the distribution on it. It's just like this is a distribution plot. So this joint plot is plotting both distribution plots and the scatter plots. All right. Here you can see that you're seeing the distribution of the fair prices. The distribution, like I said, is like right skew. So let me just show you for the sake of mentioning this. Let me just show you a graph of what the skewness looks like, so that you'd have an understanding of what we're talking about. Okay, so here, okay, so the one I clicked on, I wanted to show you. This is a bit, this is not correct. Okay, this is the one I wanted to, yeah. So here you can see that where you have the positive skew, that is the right skewed, here the hunch, or like call it the bell shape, the hunch is towards the left hand side, and then the thin lines towards the right hand side. So here you can see that the mean, the mode is less than the mean, and the median is less than the mean. So this is a positively skewed distribution where everything is dragging everything towards the center. I mean, towards the origin. The data set is being dragged towards the origin. All right. So here you can see that the data set is positively skewed. Here you have its symmetric distribution where the mean, the median, and the mode are equal. Then here you have the negatively skewed, which is a left skewed distribution where you have the mode towards the maximum value. We have the median, the middle as well. But then the mean is less than the mode. Just know that when you have the mean greater than the mode, that's a positively skewed data set. So you can read more about skewness online. All right, let's just move quickly. Here we have another plot, a beautiful plot called box plot. So box plot, you can use it to plot a categorical feature against a numerical feature. So here we have a class, that is the categorical feature, against age, which is the numerical feature. I don't know if this would work. Okay, yes, it works. I've loaded it. All right, so here you can see that what this is telling you, you can see at a glance, even without doing your pandas filter and all of that, with your visualization, you can see that it's telling you that the first class passengers, all right, it's giving you a distribution. That's what the box plot does. Giving a distribution of the age of the first class passenger, distribution of the age of the second class and the third class. So here, this is the minimum value, the maximum value, the maximum age of the first class 0, minimum age is 80, the 25% percentile is about 28, 50% percentile is about 38, and then 75% of the people on first class is about 50, the maximum age of people on first class about 80. So box plot gives you like that kind of distribution. And how do you do that, you use the SNS.box plot. They define the x-axis, the y-axis, and then define the data set you're working with, and then you can create a palette. So the palette is just the colors that you want to create. So you have the dots are like outliers, showing you that they're outliers in the data set. So the same, so here at a glance, you can see that we have elderly people in the first class. And you can see here that we have more people also as well in the first class. A lot of people in the first class. You have like compared to first class and second class, you have more people in the first class than few people in the second class, and lesser people in third class. And then we have the younger people, the younger generations in the third class. So you see the ages between 0 and 50 as well. Here you have 0 and 80. And then the median value of people in the third class are what? 20, maybe around 25 years of age, right? You have like the the young people. Then you have more of like 30 and above, 30 between 25 and maybe like around 35 in the second class, and then you have like 28 to like 50 years of age in the first class. So that's what visualization does. We have the swarm plot. Swarm plot is just like the box plots as well. It's just different type of plot with different views and ways of presenting your data. So here you can see, even though we have the third class, you can see this presentation now is looking different. Here is showing you the highest number, which we have seen in the other plots, and the least number. Again, it's showing you the stretch. That is, you have more people in the third class compared to the first class. Okay. We can also use the count plot to count the numbers. It's just like a frequency distribution of male and female in your data sets. Now you don't have to set the y-axis for the count plot. It just takes a single categorical feature. You can try to count, okay, how many males and females do I have in my data sets. Here you can see that we have like about 500 and something males. We have more males than females in data set. So if, for example, if you can also do that for your passenger class, you want to know how many people are in different classes, right? You want to know how many people are in the first class, second class. So our class is, use your class as your so here now you can see from here we have more people in the third class, and that's what our swarm plot was telling us. See, we have a lot of people in the third class compared to the first class. So the swarm plot is not really giving you a good story, but when it comes to the count of your data sets, okay? So because it just plots all the dots and then the areas where you have them. But here, your count plot gives you like a kind of a direct view. So there are some plots that are very, very easy to interpret. So at a glance, you can see some in Excel or Power BI, you call it your bar chart, okay, where you have the chart, telling you the number of what each of this column represents. You have the heat map. So the heat map is also another beautiful plot where it tells you the relationship. It plots like the correlation between all the features, where you have the correlation. A correlation is just showing you how the relationship between the different features. So the positively correlated, if the correlation is tending towards +1, that is, those two columns they're strongly correlated. If it's tending towards the minus, it's telling you that they are very, very negatively correlated. That is, when you say something is positively correlated, it could be that as one item is increasing, the other is also increasing. As one item is decreasing, that's a negative correlation, the other item is decreasing. Because say as the age is increasing, the price is increasing, or as the person's age is decreasing, the cost is decreasing. I don't know if you get that, but the correlation is just like a relationship between. So this
Its map helps you to plot the correlation. And what you supply is the correlation of that particular data set. Okay, it's time up already. I want to mention one more plot, the pair plot, which is also a very good plot, which at a glance gives you the pair of the pair of the of all the it plots all the numerical features against itself in that data set, and at a glance you're able to see the plots. Okay, there is an error. Let me check what I'm missing. Group view has no join. Okay, then there is I've selected the wrong let me see. Okay, let's do it again. Okay, so what the pair plot does, let me scroll up a bit. Okay, so it plots a joint grid. It plots a joint grid of different plots together. So at a glance, you can have different plots. You can have the bar plots, you can have the scatter plots of the data sets that you're working with, all right, that you are referencing. So let me just get the data. Because I supplied the entire data, it's supposed to be the numerical data. So I'm going to slice out just the numerical data and get the pair plot. So I'm going to slice out survive, passenger class, age, fare. Because of our time, right? Let me just do this. Okay. There's a problem. It's given an error. I don't know what the error is. I'll find out the error and get, because of our time, I might not be able to attend to this. I mean, to further debug, but let's just continue. All right, so moving on, I would like to take questions. Well, I'd like to go for a quiz break before the questions because of our time. We want to go on a quiz. Can you join the Slido link? There is this link on there's this link shared. Let me share it again. I'm going to start it up right now. Let me move this new window so that you'll be able to. Okay, you can start joining the quiz. I just started the quiz. You can start joining the quiz. You can start joining the quiz. I just posted the quiz link on the group chat. 2 persons have joined. I need more persons to join quickly. More persons. Let us do this quickly so that we can take questions. Have we started joining? Have you started joining? Okay. 5%. Please, more persons should join, please. Let's get this done quickly. I think I'll have to bring back the okay, so would wanted to, I mean, we'll be starting soon because of our time. Let us start. Why is this not showing properly? Okay. All right, so we're going to start now. Let us get started. The first question says, which commands display the first five rows of a data frame? Which commands displays the first five rows of a data frame? The first five rows. Okay, so we talked about this in class. Let's see what the answer is. It's the df.add. I mentioned df.add by default returns the first five. So it's not df.show. df.sample returns df.sample returns five samples, not the first five rows. df.first. I think let's check df.first. I know there is something called df.first. But let me find out what df.first does. Okay, yes. I know there's something called df.first, but then it supports only a datetime index. So let's read what df.first does. It selects initial period of time series data based on a date offset. So it's another Python function that when you have a Python data frame with dates as the index, this function selects the first few rows based on the dates. So you can see the sample. For example, you have a date range. Okay, this is the data set. You can see data set, it has the date index as the index. So the df.first, what df.first does is that it selects what the first, if you say there's a data frame.first, the first 3 days, that is the first, it selects the first three calendar days. All right, that is from 9, 10, 11. That is this and this. Select the first 3 days based on the data set. So it's a different function. I know there's df.first, but it's not for the first five rows. So the one that returns the first five rows is your df.add. All right, I believe that clarifies it. Let's move to the next question. Are we ready? Carl, thank you, Carl, and everybody. Let's move to the next one. To get a quick summary of numerical columns in the data frame, which function should you use? This was also mentioned. All right, so we have our answer. Wow. Quick summary of numerical columns. Quick summary of numerical columns. Let's check the answer. Describe numerical columns. I mentioned that when you're trying to get the summary statistics of the numerical columns, use it df.describe. df.info gives you the general information of all the entire data set. All right, the entire data frame. That's what the info does. Okay, so let's take note. All right, Carl, Andrew, Carl, John, Christian, and thank you all and everybody. All right, next one. Which pandas function would you use to remove rows with missing values? So we talked about that in the last class. When you have missing values, how do you remove rows to the missing value? I mean, with missing values. All right. Okay. Thank you, everyone. Let's see our answers. Drop any. So I'm glad majority said drop any. Yes, drop any does remove rows, missing value, not replace, not drop, remove, not remove any. Fill any fills in missing values. So there's fill any, which fills up missing values based on a particular strategy, a missing value strategy you defined. You can fill any with the mean value, the mode, the standard deviation, and any other strategy that you want to use, or maybe a formula, all right, used to fill in your missing values. But then for dropping your rows, okay, you have the drop any. Okay. Now let's move to the next one. Andrew, Carl, Christian, John, and Samuel. Next one, next question. If you want to check for unique values in your data column, which method would you use? Unique values. Columns. In a column, data frame column, which method would you use? All right. Okay, so let's move. All right, so 67% chose the correct answer. It's actually DF. We used it in this class. DF colon dot unique. You know, where you want to check the unique, want to check the unique manufacturer serials. We used that DF colon. That's DF manufacturer dot unique, and it returned all the unique values in our column. Now to the last question. Andrew, Christian, Carl, John, and Samuel. Last question. Okay. Which Civil function primarily used to create scatter plot? I don't know if you talked about scatter plot. Yeah, so but then you should be able to identify it. Okay, well, this is the first question that everybody is getting the answer. That's good. Kudos to everyone. All right. Congratulations, everyone. Andrew, Kristen, Carl, John, Samuel, and everyone that attempted this quiz. Hope you learned something. All right. So now let's just go to take some questions. Now's the time to ask questions. If you have questions within the next few minutes, that would be wrapping up. It's time to ask your questions. All right, the first question we'll be attending to is that, please, how can I access the serial data exploration from the LMS? So we'll be updating. So I think this data set is not there. We'll be putting it there on the class recordings page. where you have the link to the video, you also have the dataset attached, the notebook file attached as well for your practice. Okay. Do we have any other questions? Any other questions? So we'll be having our last session on Friday, and I'll be showing you what your typical capstone project should look like. So for this course, you'll be doing a project. And so we have, like, for people that are enrolled in the entire data science program, we have the three modules: the Python for data science, data analysis with Power BI, and then the machine learning basics. So you can, do your projects on any of the modules. And when you do your project for, you'll be getting your certificates for that model. All right, so you can decide to choose any of the models to do your project. So for people that chose the Power BI model, you have to do your projects, which will be turned in on the dates on the LMS. The date is specified on the LMS, and then they will be having a presentation as well, which the dates will be communicated to you. All right. How can you access the document we use? I just mentioned it, that it will be attached in the learning platform. I'm finding it difficult to access my account now. Let me check if I can access it. So that would show you where it will be linked to. Okay, not this. Let me log out and log in with the right. If there are no other questions, we'll be calling it a wrap. But then I just want to so you'll be having this under this past recordings. So we're having it here. All right. So just come there to pick it, drag to download the data sets. I mean, to download the file, the documents I'm working with. All right. Do we have any other question? When should series be used instead of a data frame when dealing with a large data set? So it depends on what you want to achieve. So there's a question that says, when should series be used instead of a data set when dealing with a large data frame? So if you want to just a series, what's a series? Series is just a single column in a data frame. Okay, so just don't mind the name. Sometimes maybe you might want to perform any operation in a single column. You can just select that column. For example, I want to do a value count of the types, the manufacturers. We've done the value count already. I want to do a value count on the type of cereal. I want to know the number of cold and hot cereals that we have. So I can just do data dot type. Data dot type gets out all the columns that are entire column. So this is a Panda series. This data dot type is just a Panda series, that is a single column in your data set. So I want to find out the value count, that is, I want to check the frequency of the number of the cold and the hot cereals. So the cold cereals, we have 74 cold cereals and we have 3 hot cereals. So this is, if you want to perform a single operation on this particular column, that's that you can use a series to achieve that. All right. I don't know if I got your question right or I'm answering it the right way, but I think from what I can interpret, that's why I'm asking. I'm answering it this way. All right. So dealing with other, maybe you want to deal with a bigger column, like more than one column. That's when you select the more than one column from a data frame. You can now do like so when you're using your dot type, you cannot select more than one column. You can do when you can do your double square brackets. Probably I want to select which I've shown you. I want to select weight and select hops. So you do value counts on just a single series. You can't do that on a double. I mean, more than one column to throw an error. All right. So you can also do rating. If you do this, it's going to show an error. So it's going to give you a key error. So you're going to enclose it in another square bracket, which gives you another data frame filtering just the weight, copper, and rating. And then you can just say, okay, I want all, I want this, I want to check the shape. That is, I want to check the size. It's telling you that you have 73 columns and but then just, I mean, 73 rows and 3 columns in this particular data set. All right, so this is just like a filter of the entire data set, just filtering out 3 columns. I don't know if that answers the question. All right. If you don't have any other questions, we're going to call it a wrap. Okay. If there are no other questions, we're going to call it a wrap. And you can keep your question coming from on the group. The group has been less active. I believe we are all still following because this is very important, and you should also, continue to own your own learning. It's very important for you to follow through that which you've started, and we encourage that everyone gets the end of this program. All right. If you don't have any questions, we'll call it a wrap and enjoy the rest of your evening. Thank you.